Chronic total occlusion, CTO, is the lesion in which a coronary artery that is completely occluded is left untreated for more than 3 months and remains occluded. It used to be an intractable condition that could only be treated with bypass surgery. PCI treatment is now mainstream, with a success rate of more than 90%. Against this backdrop, there have been major improvements in devices that result in successful treatment, and physicians have continued to put their efforts into achieving progress in medical treatment. In the late 1970s, Dr. Andreas Grunzig in Switzerland performed PCI on a human being for the first time. From the following year, live demonstrations were held annually in Zurich with the aims of familiarization with and widespread use of PCI, and these were joined by physicians from various countries, resulting in global acceptance of the future potential for PCI. In the early 1980s, on the basis of activities by Dr. Grunzig, who was invited from Switzerland to Emory University in the United States, PCI became widespread, especially in Europe and the United States, primarily for treating simple lesions. Later in the early 1980s, Dr. Grunzig investigated the feasibility of achieving the additional indication of multivessel disease with complex lesions. In particular, the need to apply PCI to CTO was discussed. Physicians used the Magnum-Mayer wire developed by Dr. Bernhard Mayer and Rotax developed by Dr. Kaltenbach. In Japan, a few physicians, including Dr. Kazuaki Mitsudo and Dr. Osamu Kato, used the standard steerable developed by USCI for PCI treatment of CTO.
PTCA devices were extremely primitive at the time. It wasn't easy for physicians to manipulate the wires in the way they wanted. A very limited number of physicians attempted to treat CTO with PTCA in Japan. And when they did, it was just a matter of, well, we gave it a try. So naturally, PTCA did not have a particularly good track record in treating CTO in Japan, and physicians didn't expect much of a success rate with the procedure. Furthermore, even if the wire passed CTO lesions, they were using balloon dilation, and the rate of reocclusions or restenosis using that technique alone was extremely high. At the time, approximately half of the cases resulted in reocclusion. For these reasons, very few people were willing to attempt PCI with CTO.
In the early 1980s, USCI developed standard steerable, a 0.016-inch PCI guide wire. With a propeller coating, this guide wire had poor torque performance and tip-shape memory, and therefore broke down readily inside CTO lesions. In the mid-1980s, a CTO device development boom took place. The devices developed include Rotax from Osipka, vibrating wire, RF wire developed by Dr. Serais, and Magnum-Mayer wire from Schneider. However, they were ineffective for treating CTO, so the momentum of the first CTO treatment device development boom declined. In the late 1980s, a guide wire series to make manipulation by physicians fully possible was developed by ACS and improvements in PCI guide wire manipulation techniques then finally became possible. At that time, the high-torque standard wire that enabled manipulation with excellent torque performance and high tip load had a diameter of 0.018 inch, and one with a diameter of 0.014 inch was developed later. However, at that time, it was considered highly dangerous to use wires with stiff tips inside the coronary arteries, so few products of this series have been sold. And they have scarcely been used by physicians other than Dr. Jeffrey O. Hartzler. In the late 1980s, the spread of non-ionic contrast agents in Japan enabled simultaneous angiography, thus enabling imaging of occluded loci and visualization of the occlusion morphology. In addition, digitalization of X-ray devices enabled the occlusion morphology and precise position of the wire tip to be confirmed intraoperatively, and the resulting dramatic improvement in wire manipulation techniques has provided a basis for advancement of PCI treatment for CTO.
Prior to this, it had been extremely difficult even to just see the fine movements of the wire tip. Since it wasn't also very easy to see it repeatedly, the advancements made in wire maneuverability had been extremely limited. It was in the late 1980s that the situation finally improved. When non-ionic contrast agents came into wide use, the simultaneous angiography I mentioned earlier became possible. The other factor was digitalization. That played a decisive role in the development of CTO treatment techniques to come.
In 1990, Dr. Takahiko Suzuki, Dr. Hideo Tamai, and Dr. Osamu Kato, with the aim of revolutionizing PCI for treatment of CTO, took what was considered unacceptable practice at that time, in that they were keen on using a 0.014-inch diameter wire, high torque standard from ACS, and thus started the main challenge with respect to complex CTO. This resulted in application of PCI to CTO being advanced to the present state in a single move.
In 1990, Dr. Tamai, Dr. Suzuki, and I agreed to work on improving PTCA for CTO treatment. The three of us agreed to work for a certain period of time to see what would happen if we used the only feasible wire for CTO, which was manufactured at the time by an American wire manufacturer, on all cases, not just a selected sample, no matter how difficult the lesion or how difficult the morphology of the lesions. I think this was in fact the most significant springboard for improvements to CTO wire technology. The idea of manipulating a wire with an extremely stiff tip inside a human coronary artery had been considered taboo. By daring to break this taboo, we could look at how the physician would need to manipulate that type of wire, particularly in terms of methods of operation, and how to deal with complications when they arise. Under these circumstances, we had the conditions we needed to learn these things. I also started out that way in 1990, which improved PCI treatment for CTO dramatically.
It was shown to be possible using high torque standard from ACS to open, by means of PCI, complex CTO lesions that had been occluded over a long period of time, thought to be impossible at that time. However, for improvement of the initial outcomes, it was considered an absolute requirement for wires that they have higher tip load and better torque performance. A visit was therefore made to the United States by Dr. Takahiko Suzuki, Dr. Hideo Tamai, and Dr. Osamu Kato to request Guided, formerly ACS, to develop guide wires for CTO treatment. However, Guided turned this proposal down.
In 1990, the three of us, Dr. Tamai, Dr. Suzuki, and I, agreed that the only wire feasible for use on CTO was one sold by an American manufacturer. However, we faced some major limitations even with this wire. One was that although we say it had a 1-to-1 torque, the torque response was not particularly good. Another was that the wires would quickly become damaged. The core of the wire was not made of steel with high tensile strength. Therefore, once the load exceeded a certain limit, the wire would deform. This greatly impacted how the wire could be manipulated. The three of us understood very well at the time that there was a limitation of the wire. I think it was in 1991 when the three of us went to the US to ask the wire manufacturer directly to develop what we needed. The reality was that the manufacturer was more concerned about the risk involved in developing wire for CTO treatment, and they didn't really listen to us.
実際上はですね、そのメーカーも CTO 向けに CTO のワイヤーをですね、開発するというそのリスクそのものの方が彼らにとっては懸念材料で、なかなか我々の言うことは聞いてもらえなかったということがあります。
In 1991, the world's first live demonstration with CTO as the main theme was carried out at Osaka Medical Center for Cancer and Cardiovascular Diseases. During fall of the same year, this course was also carried out at Toyohashi Medical Center, and Dr. Nicholas Reifert participated. Exchange of techniques and information with physicians from Europe and the United States subsequently became frequent. BARI study, a large-scale multi-center randomized study of the initial and long-term outcomes of coronary artery bypass grafting and PCI, was started in 1988, and the screened subjects' background factors were published in 1991. According to that report, 68% of the patients with multivessel disease had CTO, and in 70% of screened subjects, the presence of CTO was the reason for selecting CABG rather than PCI. It was thus again recognized that CTO must be obtained as an additional indication for the use of PCI to become more widespread. The second CTO device development boom took place on the basis of the BARI study. The products developed include the following: Choice Guide Wire from Boston Scientific, Shinobi Guide Wire from Cordis, Crosswire from Terumo, Prima Laser Wire from Spectranetics, Safe Cross System from Intraluminal Therapeutics, and Frontrunner from Lumend. In 1992, Dr. Osamu Kato was not satisfied with the torque performance and tip durability of the CTO wire from ACS and concluded that improvements had to be made from the stainless steel material. Therefore, focusing on the high elasticity and rigidity of the principal initial stage wire products of ASAHI INTECC, and their cores being more nearly circular than those of other companies' wires, and stating that if made by ASAHI INTECC, products may be better than the existing CTO wires. He requested ASAHI INTECC to develop guide wires for CTO. This led to the launch of Athlete Standard.
ASAHI
INTECC had a wire called Athlete Standard, which had been developed by imitating standard wire produced by the American wire manufacturer. This meant that it also had performance limitations. We compared the core of the wire made by the American manufacturer and the core of the ASAHI INTECC wire. Compared to today's wires, the structure of those wires was very simple, with only a coil wrapped around the core so that just by removing the coil, you could see the core itself. You could even touch it. When we compared those wires, there were definite differences. One was that core of the ASAHI INTECC wire was extremely rigid, like piano wire, and did not easily bend or deform. This was clearly different from the American manufacturer's wire. When I saw this, I knew right away that we could get a better product if we could get ASAHI INTECC to develop the CTO wires. So we immediately contacted ASAHI INTECC and asked them to make a CTO wire, explaining what the three of us wanted, and that is how the development process started.
In March 1992, ASAHI INTECC completed development of the Athlete Series, Japan's first PCI guide wire. It was launched in Japan in 1994. In the collaborative development by ASAHI INTECC and certain physicians, highly sensitive requirements for greater softness or stiffness of the wire tip were expressed numerically, and the tip load was expressed in grams. As a result, for the first time, the sensation on the part of the physician using the device was converted to physical characteristics. Dr. Isao Kinoshita submitted an article regarding the initial outcome obtained by Dr. Osamu Kato in the CTO Challenge, using CTO wires from ACS and ASAHI INTECC. It was published in JACC in 1995. This report showed the feasibility of increasing the success rate of PCI for treating CTO, which had previously been low, and it thus had a major global impact. It has since been referenced in various publications. Dr. Takahiko Suzuki started using IVUS a great deal when treating CTO. Using IVUS, it was possible to obtain information about the position of the wire tip inside the vessels, the CTO lesion tissue composition, and the intravascular distribution of these tissues. It thus became possible for a small number of the most advanced CTO specialists to use IVUS to treat CTO. This accumulation of IVUS information made it possible to understand the responses of CTO tissue to CTO wire manipulation, and this has made a major contribution to the progress of CTO procedures in Japan. ASAHI INTECC received a request from Dr. Takahiko Suzuki to produce guide wires for treating CTO, and collaborative development was then carried out. The request stated that in particular, wires should be made that would cross the difficult lesion, especially with calcification. The coil diameter of the tip was increased, And at the same time that Dr. Osamu Kato's opinions were incorporated, a controlled drilling type wire was developed as a concept, with the importance of torque force emphasized. Miracle was launched in Japan in 1995. The resulting product dramatically expanded CTO treatment by PCI.
That was some 20 years ago. We decided to start by disassembling the entire wire, and because there may have been patents and other issues involved, we considered many different possibilities to develop a different structure. We figured that the rigidity and thickness of the core wouldn't have anything to do with torque. The spring coil would be a problem, so we thought we would not use the same coil. Although we do have it now, we were developing the coil braided with 2 or 3 wires. Or other possibilities, like a rigid core but a tapered design and making the torque as strong as possible. We tried many different designs. That's how it started and how the Miracle developed. We had several candidates for names, but I felt Miracle was the best, so that is the name we went with. However, for the concept behind the Miracle, each of us, myself, Dr. Kato, and Dr. Tamai, had very different ways of operating the wires. We may look at the same lesion, but the stiffness we want and the way we rotate the wire may be different. So there isn't just one type of correct CTO wire. In terms of CTO hardness, it also depends on bending. It may be the same shape and hardness, but it becomes more rigid as it bends. Also, there can be calcium that is invisible to the eye that makes the CTO harder than it appears, much harder. This is typical of CTO. So physicians have to step up or, in some cases, step down as they go along. The fact is that from the concept stage, we were working on different types of stiffness for the wires. Physicians also are each different, and we instructed ASAHI INTECC from the outset to listen to many different physicians. It meant we ended up with too many prototypes. We had too many, so we had to narrow these down. When we asked ASAHI INTECC to develop the CTO wire, one of our requests was a high-load wire. It's hard to imagine now, but unfortunately, that type of wire was extremely difficult to manipulate at that time. This meant you'd have to have features of other wires to control the CTO wire. Without a guarantee of wire torque transmission, manipulating a stiff wire in a coronary artery is next to impossible. So the next thing we needed from ASAHI INTECC was a wire with a strong torque. To strengthen the torque, ASAHI INTECC tweaked the coil wrapped around the wire and developed a wire structure for very strong torque transmission. This was the Miracle. I remember back then using the wire while working on CTO in a human coronary artery and being extremely impressed. When the wire was later sold outside of Japan, physicians overseas were similarly surprised. However, our understanding of CTO wires at the time was still very basic. So naturally, the wires were developed based on our limited understanding. So they were limited in terms of performance.
In 1996, Dr. Osamu Kato visited Germany as a consultant cardiologist in CTO for Dr. Nicholas Reifert. Dr. Kato met and exchanged techniques and information with 2 physicians who are well known in the CTO field, Dr. Antonio Colombo from Italy and Dr. Bernhard Meyer from Switzerland, and provided them with the guide wire Miracle. It was then decided that ASAHI INTECC's PCI guide wires would be rolled out in Europe.